In this video, we are looking at direct proportion. From the previous video, you should know that two quantities are directly proportional to each other if, when you multiply one quantity by a scale factor, you multiply the other quantity by the same scale factor. For example, if 1 kilogram of potatoes costs £2, then 7 kilograms must cost 7 times £2, which is £14. We say here that the cost of potatoes is directly proportional to the number of kilograms you want to buy. Because if you multiply the number of kilograms you want by a scale factor, you need to multiply the cost by the same scale factor. Now, in this example, we are told that y is directly proportional to x. We are also given that when x is 10, y is 70. First, we need to complete the table. So let's think. If x is 1, what would y be? Remember, if we multiply x by a scale factor, we would have to multiply y by that same scale factor. So, to go from 1 to 10, we would have to multiply by 10. And that means to go from this y value to 70, we would also have to multiply by 10. So that missing y value there is 7. We could work that out in reverse. Going from 10 to 1 is the same as multiplying by a tenth, which is the same as dividing by 10. So to work out the missing value here, we would start with 70 and multiply it by a tenth, or just divide it by 10. 70 divided by 10 gets you to 7. Now, what about when x is 2? Well, to go from 1 to 2, we multiply by a scale factor of 2, so we need to do the same thing here. We take this 7 and multiply it by a scale factor of 2, and that gives us 14. What about when x is 3? Well, to go from 1 to 3, we're multiplying by a scale factor of 3. So what do we do here? Well, we'll start with 7 and multiply that by a scale factor of 3, and that gives us 21. Pause the video and see if you can complete the table. Here's what you should have got. Notice, whatever x value we start with, if we multiply that by a scale factor, we have to do the same thing to the y value. For example, if you start with 10 and you multiply that by 3, you get 30. Notice, 70 times 3 gives you 210. This is a really big idea when you've got two quantities that are directly proportional to each other. In question B, we need to write a formula for y in terms of x. Now, if y is directly proportional to x, we can always write a formula that links x and y in the form y equals kx. So that's y equals k multiplied by x. K here is called the constant of proportionality. By the way, sometimes people write y is directly proportional to x like this. They use a special symbol. Y is directly proportional to x. Anyway, as I said, when y is directly proportional to x, we can write a formula of the form y equals kx. We just need to work out what k is. We can pick any pair of values from this table to see that whatever x is, you have to multiply it by 7 to get y. So this constant of proportionality is 7. So that means our formula is y equals 7x. In question C, we need to find the value of y when x is 0.6. Well, we can use this formula. Y equals 7x. So when x is 0.6, y equals 7 multiplied by 0.6, and that gives us 4.2. So there's our answer. When x is 0.6, y is 4.2. Notice, by the way, how this fits in with what we understand about direct proportion. If I temporarily replace this column in the table, and we have x being 0.6 here, and y being 4.2 here, notice that you need to multiply 0.6 by 10 to get to 6, so we need the same scale factor, and we do have that. 4.2 multiplied by 10 gives us 42. So this fits in with what we've learned about direct proportion. Moving on to question D, we need to find the value of x when y is 38.5. We can use the formula again, but this time we need to do a bit of rearranging. Well, we know that y equals 7x. Substituting y equals 38.5 into that formula, we get 38.5 equals 7x. And if we divide each side of the equation by 7, we get x equals 5.5. And there's our answer.